Hello everyone, I'm Nazifa Tabassum Khan and my group member is Mostofa Faruk. Today we are going to discuss about the impact of total harmonic distortion and power factor on power grid due to EV charging. Before going to the presentation, I would like to draw the outline for the audience to make it more clear. Firstly, I'm going to give you an insight about EV and the significance of EV in modern technology and discuss the problems and challenges associated with EV charging. The problem statement and objectives for this project will be discussed. Furthermore, the proposed system will also be discussed. The audience will get an insight of complex engineering activities and problems. Later, the design, mathematical modeling, simulation, and hardware prototype will also be discussed. Lastly, we will analyze the results and results obtained from the acquired data. Finally, we will draw conclusion on this project and talk about some future scope for this project. As we know, the world is increasingly trying to adopt green energy, lower pollutions, and sustainable transportation system. Electrical vehicles will be one of the dominant transport systems of the world. According to the World Energy Council, almost 17% of the greenhouse gas discharge to the environment is produced from the transport sector. In Bangladesh, the transport sector plays a vital role in greenhouse gas emission. Though in Bangladesh, electrical vehicles are not that much popular yet, battery-run three-wheeler auto rickshaws are gaining popularity as it's used in both urban and rural areas for public transport. It can produce a fundamental job in the mass and green transportation, work creation, and advancement of new industries. As there is no use of fuel in EV and no emission of greenhouse gases, it doesn't pollute air and is environment friendly. The fast growth of electrical vehicle market has advanced the energy sector as exploring area for the researchers from all over the world. The use of electric vehicles are expanding these days because of their potential for lower usage of fuel, a decrease of carbon footprint, and their capacity to implement sustainable energy source in the transport sector. EV infiltration in Bangladesh requires more than 500 megawatt of power every day. The major problem with EV in Bangladesh is there are many unplanned charging stations. For charging EV, the same grid is used as the households. Charging from grid electricity, EV charging becomes costlier. The demand for huge power makes it a difficult problem with the current demand. EV chargers are similar to nonlinear load. These are mainly power electronic converter. The nonlinear attribute of EV charger may deliver harmonics in the current and it can impact the voltage profile of the grid. For the high nonlinear load, nonlinear voltage drop happens and for the voltage, waveforms can be distorted, such as increasing of total harmonic distortion, affecting the voltage profile and power quality as well. Every year, for this, a lot of power loss happens. If we can decrease this harmonic disturbance, that will lead us to less power loss. Thus, by saving the power, we can charge more EV at the same time, and the quality of power in our national grid will be decreased. Charging of EV requires high force and huge time. However, their range isn't agreeable. There is a vast pressure on the national electric grid. Moreover, there is a lack of adequate charging station in Bangladesh. In this way, the EV proprietor needs to charge their vehicles from residential associations unlawfully, which turns into a reason for the power loss in the country. Here, for literature review, we observe that many methods have been used to analyze the impact of EV charging. such as simulation technique and stochastic modeling. Several parameters were examined using MATLAB Simulink and analysis of PEV's daily consumed power from the grid in the specific periods and peak characteristics in the EV parking areas and so on. However, there are certain limitations to this. The mitigation technique proposed is solar energy and solar-based charging station, which is costly and tough to maintain. The Monte Carlo simulation took a huge iteration rate that required a computer of high specification, etc. Some possible solutions for these problems are Monte Carlo simulation has been used to take several uncertainties into account. It considered the data of only a campus. A wide range of data could give a more precise idea of the effect. Power electronics converter can be proposed to mitigate the effect where solar-based charging station isn't possible. For this project, addressing the problems such as stochastic programming was used instead of a real household. And for keeping the power quality inside as far as possible, it is important to consider ideal charging and deal with the connected load by the EVs. The voltage quality is redressed. Otherwise, our objective is to design and develop a system that can properly measure the total harmonic distortion due to EV. We have taken measurements from EV charging station of Dhaka. By using the data and analyzing the data, we got a proper knowledge about how much harmonics are produced by EV charging system. From analyzed data in simulation, how EV charging is affecting the power quality of the grid will be addressed. Overall, our power sector will be benefited from the improvement of the power quality, and we will get greener environment by using EV. Here is our proposed system designed to measure total harmonic distortion due to EV charging. A single-phase AC source is connected to the data acquisition system and is also being used to charge the EV. While EV is being charged at the same time from the single-phase AC source, voltage and current readings will be taken using data acquisition system. And finally, collected data is stored in a storage system. We will use the stored data to analyze and measure total harmonic distortion due to EV charging and its impact on power quality. Every project has some complex engineering activities and problems. In this part of the presentation, I will give an insight about the complex engineering activities and problems of this project. This project requires AC-DC circuit analysis, embedded systems, sensor and instrumentation, power electronics, and computer programming knowledge. There is no unique way to design this project. A depth of analysis is required to select a specific solution from many alternatives. Some unfamiliar issues were encountered while conducting this project, such as EV technology, EV battery, EV charging system. The code applicable for this project is IEEE standard 5191992. The stakeholders for this project are power distribution company, government agency, EV owners, and passengers of EV. Microcontroller, sensor system, data acquisition system, data storage system, power supply systems are all interdependent in this project. Now I would like to call my group member, Mostofa Faruk, to continue the rest of the presentation. Thank you.
Hello everyone. Now I'm going to discuss about the complex engineering activities of this project. Money, people, components, MATLAB Simulink, EVs and information are required to implement the project. Some interaction with EV owners was required during the data acquisition of the project. The THD measurement system is an innovative system. The project will improve power quality, ensure efficient use of energy and reduce combustion of fuel and decrease emission of greenhouse gases. It is environment friendly. Some unfamiliar issues encountered in the project are EV technology, EV charging, EV battery, etc. Here are some formulas we have used in our project. In this section, we have simulated a conventional charger and demonstrated the input and output graphs. Since we have used ideal transformer, we observed that the input graph for voltage don't show any distortion, which implies that there is no harmonics. However, the input graphs of current shows some harmonics, which is due some distortion, which is due to harmonics. Here's the simulation of our hardware prototype has been demonstrated. The upper portion is for conventional EV charger. In the lower portion, using a differential amplifier, the grid voltage is stepped down and DC offset is added so that the negative cycle is also shifted to the positive side as microcontroller cannot handle negative value. The ADC value is measured and scaled further. Similarly, for current using CT, we got the measurement. This is the simulation. This simulation demonstrates the circuit for measuring real-time power factor. From 2 op-amp, we got the value of current and voltage. Then the output of XOR gate is connected to digital part of the Arduino. The time difference of XOR gates output to be 0 and 1 is calculated by Arduino, and using this time difference, power factor can be calculated in real time. This is the hardware prototype of data acquisition system of our proposed system. A single phase AC source is connected to the data acquisition system and EV charger. When the switch is turned on, data is stored in the storage system and EV gets charged. At the same time, voltage and current was measured during using voltage and current sensor through Arduino Nano. Here we can see the waveforms of current and voltage for fully resistive load and EV charging. Comparing the two, we can say that the EV charging, the waveform of current and voltage is distorted, which is due to harmonics. Here we have determined the phase difference for fully resistive load and EV charger using DTFT and later calculate the power factor. For fully resistive load, the power factor is 0.8242 and the for EV charging, the power factor is 0.71. For EV charger, power factor is less, which means the real power is less and the reactive power is more. The greater the reactive power, the greater the power loss. This means that the power quality of the grid is degraded. Here we have analyzed voltage and current harmonics for fully resistive load at 50 Hz frequency, and for the resistive load we got THD of 1.29%, and for the EV charging we got the harmonics of 4.12%. Combustion of fossil fuels causes greenhouse gases to be released in the atmosphere. Burning fossil fuels causes air pollution and acid rain as it releases toxic gases into the atmosphere, and it is also responsible for the rise in temperature of the earth. This increase in temperature further causes the glaciers to melt and it turns there a rise in sea level. To curb global warming, it's essential that alternatives to fossil fuels are used to reduce emissions. Clean and green energy should be widely used. More energy efficient technology should be implemented. Electric vehicles are powered by electrical energy, and thus the fossil fuel consumption can be reduced. Most power stations in Bangladesh are powered by fossil fuels, and thus it is crucial to make sure that the consumption is done wisely and responsibly. This project not only reduces the use of fossil fuels in the transportation, but will also improve the quality of the power, which was otherwise being affected due to the harmonics produced from the use. Overall, in this project, we have designed the developed THD measurement system of EV charging system, collected and analyzed data, and determined the impact of EV charging and power factor on the power quality. The future scope of this project is a system can be designed to show real power, reactive power, and power factor, and THD in LCD real time instead of data acquisition system that we have done. Thank you.